Hello students, welcome to today's mathematics class. Today we learn about types of discontinuities. First let us discuss the discontinuity criteria. What is the criteria for discontinuity? Let f is a function from S to R and is a point in S, then f is not continuous at A if and only if there exists a sequence xn in S such that limit of xn is equal to A when n tends to infinity, but the limit of f of xn is not equal to f of A. So this is the discontinuity criteria. Whereas in continuity, we see that limit of xn is equal to A, whereas limit of f of xn is equal to f of A. That is the criteria for continuity. That criteria continuity fails in this discontinuity criteria. That means limit of f of xn is not equal to f of A. Next, what is the example? Let us take one example. F of x is equal to 1 by x for x not equal to 0, and f of x is equal to k for x is equal to 0. This function is not continuous at x is equal to 0 because at f of x, the limit of f of x at x is equal to 0 is 1 by x, but it is not equal to k. Types of discontinuities. First one is a removable discontinuity. If limit of the function at a exists, but that limit is not equal to the function value of f at a. Actually, if it equality holds here, this becomes continuity function. Here what we observe that the limit of the function f of x is not equal to f of a. Therefore, this is discontinuity function, and this type of discontinuity is called removable discontinuity. In such case, we can remove this kind of discontinuity by defining a new function g such that g of x is equal to f of x for all x not equal to a in the domain of f, and g of a is equal to limit of the function f of x at x is equal to a. Then g is obviously continuous at a. Let us discuss with an example. Consider f of x is equal to x square minus 4 by x minus 2. This function is for all x not equal to 2, and f of x is equal to 0 for x is equal to. Here we observe that the limit of the function f of x at x is equal to is 4. Why? Because okay, so a limit of f of x, a limit of x square minus 4 while x tends to 2 by x minus 2 is equal limit x minus 2 into x plus 2 by x minus 2 while x tends to 2 is equal to limit of f of x plus 2 while x tends to 2, that is nothing but 4. Here both will get cancelled. So since the function limit of the function f of x is equal to 4 when x tends to 2, which is not equal to f of 0, because f of 0 at x is equal to f of x is equal to, so this is 2. Okay, this is not equal to 2. This is what it is. So limit of the function f of x is not equal to f of x. Therefore, now we remove this discontinuity for f by redefining, by introducing a new function g such that g of x is equal to x plus 2 for all x not equal to 2, and g of a, that means g of a means g of 2. Let us write 2. This is 2. Okay, right. This is 2. And g of 2 is equal, and g of 2 is equal, and g of 2 is equal limit of f of x when x tends to, where g of 2 is equal to 4, where g of 2 is equal to 4. So like this, we defined g function. So in this case, g is continuous. Second is discontinuity, jump discontinuity. If limit of f of x from left, that means left side limit of f at a and right side limit of f at a both exist, but both are not equal. In this case, we call this kind of discontinuity as jump discontinuity. We consider an example, that is f of x is equal to x minus box x at x is equal to. We discuss the discontinuity of f at x is equal to 1. Here, left limit at a, that is denoted by f of 1 minus 0, is equal to limit of f when x tends to 1 from left side. This is nothing but f of x means x minus box x. From left side, the values of x from to the left side of 1 are 0 0.0. So that the limit of box x means this is integral part function. Therefore, 0 point something, 0 point something of box value is 0. That's why I put here 0. And the limit of x, suppose x tends to 1. Hence, limit of x is equal to 1. So, 1 minus 0 is equal to 1. And the right side limit at a, f of 1 plus 0 is equal to limit of f of x when x tends to 1 from right side, that is equal to limit of x minus box x. Limit of x when x tends to 1 is 1, and the limit of box x when x tends to 1 plus x tends to 1 from right side. Therefore, for right side values of x for 1 is 1.1.1. Therefore, box x means box 1 point. Hence, the integral part is 1. Therefore, limit of x is equal to 1 minus limit of box is equal to 1. Hence, 1 minus 1, 0. Limit, left side limit is 1 and right side limit is 0 at 1. Therefore, both limits exist but are not equal. Therefore, it has jump discontinuity. Note, a removable discontinuity or jump discontinuity of a function is called first kind of discontinuity or simple discontinuity. So we call the jump discontinuity or removable discontinuity. The other name is for that jump first kind of discontinuity or discontinuity of first kind or simple discontinuity. So if anybody asks you what is first kind discontinuity, if anybody asks you like that, then you need to give answer whether it is jump discontinuity or whether it is removable discontinuity. Third, second kind of discontinuity. So second kind discontinuity. If at least one of the limits, either left limit or right limit of f at a is non-existent or infinite. what will happen? Limit is not exist or infinite. So we don't get finite value or as limit. So this kind of discontinuity is called second kind discontinuity. We consider one example, f of x is equal to 1 by x minus a for all x not equal to a and f of a is equal to k. Here the left side limit of f at a is minus infinity. Why? Because limit of f of x when x tends to a minus equal limit f of x means 1 by x minus a, x tends to a minus is equal 1 by 0, that is equal that is minus infinity, right? So the minus side limit, okay, minus infinity. Other hand, limit x tends to a plus f of x means limit x tends to a plus 1 by x minus a is equal to 1 by 0, that is equal to 1 infinity. So here limit not exist. Left side limit is going to minus infinity and the right side limit goes to plus infinity. So here limit not exist and infinite. Therefore, f has a discontinuity of second kind at x is equal to a. Okay, students, learn these definitions and observe the examples and take notes. Okay, thank you.